So let's understand about understanding of wireless networks. So we have a good experience how to implement networks in infrastructure, like devices, these wide connected Cisco routers and switches. Similarly, same thing, how to implement networks and protocols in wireless devices and what type of wireless devices do you have. Just introduction part. For wireless, we have a separate course actually. So in CCNA, we need to understand that wireless, how it works actually. So wireless LAN, one type of wireless network is a type of wireless network that is commonly used in homes, offices, and campus networks. Basically, what type of networks do you have in LAN, in wireless? See, have different types of wireless networks. The first type is personal area network, PAN, local area network, LAN, metropolitan area network, MAN, wide area network, WAN. These all are different type of networks generally we have. Similarly, in wireless networks also, WPAN, wireless personal area network, WLAN, wireless local area network, wireless metropolitan network, wireless wide area network. So out of these types of networks, the most commonly used wireless network is WLAN, local area network. Best example, your Wi-Fi, because the short range you are connected to your Wi-Fi router, the local area, wireless local area network. So the point here, a wireless LAN is type of wireless network that is commonly used in homes, offices, and campus environment. Wireless LAN make mobility possible within the home and business environment. The main advantage of wireless is mobility, like flexibility will be increased actually. So how these wireless networks works uses radio waves to connect technological devices to internet as well as your business network. Based upon type of media, bits are transmitted in signals. Remember in OSI, physical layer we discussed, like based upon type of media. If it is wide, it is RJ45. So inside RJ45 wide, there is copper. So copper wire will pass electrical signals. But for wireless, wireless radio waves, radio frequency waves will be passed actually. That data transmission will done with radio frequency waves. So types of wireless networks are, is all are different type of wireless networks we have, like a WAN, WPAN, wireless personal network. So which can provide a short range, it's low power and short range, 6 to 9 meters. Based on IEEE standards, it's 802. Remember, if any technology start with 802, is a LAN. 15 is a PAN personal network. The best example for PAN is the Bluetooth, Zigbee, is technologies. Wireless LAN is commonly used, so it can support medium sized networks up to about 300 feet. 802.11. If you see your mobile phones, you can get 802.11 standards, 11G, 11A, 11B, like that. Wireless metropolitan area network, large geographic such area like in districts. No telephone towers we can see, which can provide the district-wise, city-wise signaling. That is wireless metropolitan network. To exchange the signals, they required used specific licensed frequencies. Wireless WAN is global communication, satellite signals. Geographic area for national and global communication. So it's also licensed frequencies. There are different types of wireless LAN networks we have. If you see advantages and disadvantages of wireless networks. What is the main advantages for wireless? Yes, that's the main major advantage. This is your office building and ground floor, your first floor, second floor. And as an employee, you are in ground floor. You're sitting in a ground floor with a laptop. So nearby ground floor, the access point, which is providing the signals to you, and you got connected internet actually. So your job role demands to move for meetings, for discussions, like for promotions. Like you're moving from ground floor to first floor to second floor, ground floor. So whenever you move, your laptop is a part of network. It did not disconnect from the network actually. Mobility. So wherever you're roaming within a building, your laptop is connected actually. Because when you are moving from this wireless access point zone 1 to zone 2, then immediately next access point will connect you actually. You're part of network. You're moving here, you're moving here. Anywhere if you move, your device will not disconnect from network. It's a part of network only actually. But if you are connected to wire, now you want to move to first floor. So remove the wire and need to move. Once you remove the cable, you disconnect from network. So there is a drawback in wire. If it is wireless, like we can move around and complete your office zone, the part of a network. So like this, better mobility, cost effective, scalability, there are advantages. But disadvantage is what? Compared to wired, wireless is less speed. Wide media, we call it is wide, call it is what? Guided media. What about wireless? Wireless is unguided media. Means when wired have a guidance, like signals must pass through this channel. Via this channel, from one device, your signal passes this channel. It says guidance action. But what about wireless, unguided? From this device, how to signal pass to this destination device? So your device in right side. Now what this device will do now? This device will send the data transmission in all directions. So this direction also received. So from here, if you're moving to somewhere, signals will strong, or some moving to somewhere, signals will be low. So we don't have any proper guidance how the data traffic has to move. In wireless, data will be moving around all directions actually. In any one of the direction, your destination device available, it gets signal. It receives the transmission. But in wired, we have proper guidance. All data should pass through this cable, then faster. So compared to guided, wireless is less no, slow actually. And security also is a main important point. So how data transmission is happening in wireless devices? Data transmission will go with one direction, another direction, one more direction, another direction. So when signals are passing in all directions, someone is here sitting here, they can tap your signal and they can capture it easily, or they can, they can use to stop jammers. They can use to destroy the signals. So we can easily manipulate because the medium is air. If data is going to medium is the air, we can be disturbing actually. Signals destroyed, the jammers you can use. So security issues will come actually. Compared to white. White is so all data securely should go via wire only. Security issues, less speed, less control. Control also less actually. We don't have much control of your data because in all directions data is moving. We don't have much control. Is the disadvantage of wireless. So corporate networks mostly they'll use wired connectivity only for faster communication, for secure communication. Like where exactly you required a more mobility, then you should go with the wireless. Got it? So wireless technologies. So what type of technologies in wireless we have? Bluetooth is also wireless technology. Wi-Fi, WiMAX, cellular broadband, satellite broadband. These all are different type of wireless technologies we have. So how Bluetooth works? Sending information over ultra high frequency radio waves to operate this within industrial, scientific, and medical radio bands like ISM, Bluetooth. The ranges, frequency ranges 2.4 and 2.485 gigahertz. Like in cables, we have 10 Mbps, 100 Mbps, 1000 Mbps, 10,000 Mbps. Like in wireless, data transmission between frequencies, hertz, kilohertz, megahertz, gigahertz, like this. So hertz means number of cycles per second. So most commonly used technology in entire wireless technology is Wi-Fi technology, so which are commonly used for local area network of devices and internet access. This is 802.11. How to set up this Wi-Fi? So first thing you will need access point. I mean your Wi-Fi router, right? We'll purchase one access point from any vendor and we'll give power switch on it from device. We log in and create some SSID name, network name, and we configure password. That's all. And save this configuration part, right? Then all users can access this device actually. So what type of device we can connect through Wi-Fi? Devices that can use Wi-Fi technology, including your desktops also, laptops, microphones, smartphones, tabs, smart TVs, printers, digital audio players, digital cameras, cars and drones, like all. If you check with IoT, so there are so many smart devices, a lot of them can be connected with the Wi-Fi actually. like this. So WiMAX is cellular broadband, like within a city, within a district, residential areas, it can provide signals. This is one type of wireless technology that provides wireless internet service for longer distance than standard Wi-Fi. So standard Wi-Fi can support in meters range only, right? 50 to 100 meters. But it can provide kilometers, 50 kilometers to 60 kilometers away. So these fixed and mobile stations to provide users to access high-speed voice transmission, data, and internet connectivity. Yeah, cell phone tower symbol actually. Cellular broadband we know well about how the technologies we developed, 2G, 3G, 4G, 5G technologies. So first wireless internet access became available in 1991 as part of the second generation, which is 2G technology. The amendment of 2001 and 2006, 3G and 4G generations are introduced. Now we got a 5G also. Like GSM, CDMA. Remember? It's like early days we used to CDMA mobile phones. Now all GSM technologies. And satellite broadband. So what is exactly this frequencies, radio frequencies, transmission the data? This is your Wi-Fi device. I mean your laptop or mobile phone. And you're connected to your nearby access point. So wireless access point will generate electromagnetic signals to transmission data. It will generate electromagnetic signals in spectrum, like in all directions. Signals will start. So if we take on some straight line, signals will raise up and fall down, and again raise up to meet the straight line. So complete cycle is complete one cycle where signals is started and raising up maximum, and falling down maximum, and reach the same point. This cycle we called hertz frequency. So for 1 second, how many frequencies mean? How many cycles is happen? Number of cycles per second. Call hertz. One, again raise up, down. Two, raise up, down. Three, raise up, down. Wait. So these cycles happen. How many cycles happen for 1 second as per this diagram? So this 4 cycles is done in 1 second. So in these signals, what type of signals will generate is some signals are electrical signals. And signals are magnetic signals. Electrical signals, magnetic signals will pass action. How many cycles is done for the 1 second? Says 1 cycle. Right? This is 1 cycle. Again, says another cycle.
4 cycles.
So 4 cycles per second. So we call hertz. Number of cycles for 1 second is hertz. Now our Wi-Fi routers are supporting gigahertz. So mean per 1 second, how many cycles is happening? Kilohertz, megahertz, gigahertz. So 2.4 gigahertz times the cycles is happening actually with the combination of electro and magnetic signals. That's the spectrum. See, 802.11 BGN, which is virtual LAN, wireless LAN networks operate in 2.4 and 5 gigahertz frequency bands, which is very high transmission band actually. So we have different vendors in the market. It is developed by D-Link, TP-Link, many vendors. But main thing is we need to understand this radio frequency waves. So initially 802.11 is a wireless. Radio frequency is just 2.4 gigahertz and data rate up to 2 Mbps only. Very low. So later sometime 802.11a was developed with 5 gigahertz cycles. Even data rate is what? 54 Mbps. 11a, 11b, the low 11 Mbps only, but longer range can support. A high-end technology, high data transmission rate is started with 802.11 G, 2.4 gigahertz, 54 Mbps, and backward compatibility of 802.11 B. 11B can support a longer range, but speed is how much? 11 Mbps only. But 802.11 G is backward compatibility of 11B and with high transmission, which is 54 Mbps. These all technologies works with single in, single out CISO technology. That is why maximum is 54 Mbps. Whereas later 802.11 NACAX high transmission. 100 Mbps, 150 to 600 Mbps can support. Required multiple antennas with MIMO technology. Means multiple in, multiple out. CISO is single in, single out, multiple in, multiple out. Then data transmission is higher. 100 Mbps to 500 Mbps, 600 Mbps, 450 Mbps to gigabit, and we call it is HEW, high efficiency wireless. 1 gigahertz to 7 gigahertz frequencies can support actually. Capable of using this. 11AX, high-end technologies. Got it? The next point about wireless topology. Star topology, bus topology, ring topology. We have different type of topologies. Right? In wireless topologies, see here two devices are directly connected without any infrastructure, without any access point. Laptop 1, laptop 2, or they can directly connect with a hotspot. Agree? If you are sharing the hotspot, you can connect. Access point is not required. So peer-to-peer manner without an access point at hack mode. Infrastructure mode means all devices are connected to access point. So we need one access point used to connect clients to network using API access point. So variations of ad hoc topology is when smartphone or tablet with cellular data access is enabled and create to personal hotspot. Tethering. Like ad hoc mode via hotspot. So these are the different options we have to connect devices with wireless. You can connect to wireless, access point, or directly device to device, peer to peer manner, or shared network, which is personal hotspot, like this. Then what type of components do you have in wireless networks? Wireless NIC cards, wireless antennas, wireless router, wireless access point, wireless controller, LAN controller. These are all different type of components you can use in wireless network. Wireless NICs will use for like basically desktops. Desktops can support what type of connectivity? Wired connectivity. But you want to use your desktop as a wireless, then you purchase one external wireless NIC card and insert in your connect your motherboard. From desktops also you can access it. This is to communicate wirelessly or laptops or tablets. When they'll come with the default wireless NIC cards, your laptops and all. What if device does not have an integrated wireless NIC? Then you can use USB wireless adapter can be used. This is wireless NIC cards. Wireless antennas. So to transceiver, the transmission and receiving converts radio frequencies into the current. So your antennas plays an important role in operations of all radio frequency equipment. To receive the signals, to regenerate the signals, antennas will be useful. Different type of antennas we have. Omnidirectional, directional. No, the traditional antennas are directional antennas. Focus the radio signals in specific direction only. Your dish antennas. Remember, guys, early days. It just we need to move around. So when you got a signal, the same direction, you'll get the signals. If you move it, signals will not come. The specific direction only you'll get it. Omnidirectional covers all ranges, 360 degrees coverage. So multiple input will increase your bandwidth to receiving and transceivers. Wireless router used for connecting your wireless devices. Everyone knows about wireless uh, access points and switches. This device, right? Using for Wi-Fi. WAN port, LAN port, power switch, reset button. Have you configured your Wi-Fi router? Anyone? Have you logged in? What you are using in your homes? I hope everyone are connected to Wi-Fi right now from your laptops or mobile phones. Do one thing. You just open the command prompt and check ipconfig. Then you can see your default gateway address. This is my default gateway IP address 192.168.0.1. So open your browser. From browser, one nine two dot 168.0.1. It will ask login credentials. 192.168.0.1. Client closed connection at 168.0.1. So what vendor device I'm using? It's a D-Link. Username. Let me use default username admin. Password is password. Change your password. Password you just used. Found in data breach. Google password manager. Now, yeah. So I log in my Wi-Fi router. You can see. So internet connected to Wi-Fi router to end device. The diagram which we are regularly drawing, right? What is the diagram I used to do every day? Router connected to switch and switch to end devices. And router connected to ISP. ISP to internet. Same diagram you can see here. From internet, we are getting one connection to Wi-Fi router to end device. So for this Wi-Fi router, currently there are 4 clients, 4 devices are connected. So what devices are connected? You can see this. One mobile phone, and remaining are desktops are connected. You want to configure anything? You can just go to settings. Yeah. So first you can get the basic information here. Connection type is dynamic IPv4. Status is connected. Uptime 1 day. Before 1 day, this Wi-Fi router might be rebooted. IP address, which is coming from service provider, and gateway is this. And I'm going to via this DNS server. So you want to do the settings, you can go to settings. Connection list, I have only one link. Connection type is dynamic IPv4, status is connected. Internet settings you want to do or wireless settings you want to do, you can click on wireless network. So changing SSID name and changing password, Wi-Fi password, here I can do it actually. Okay. Want to manage the network, you can manage it. System administrator. See telnet. Telnet, you can enable or disable access the device via telnet from your LAN. Is enabled or disabled? It's already enabled. So how we can log in? I can log in through telnet also. Telnet, the Wi-Fi router is 192.168.0.1. Admin, password is password. Like you can configure now. So we need to get the commands, like how to configure these dealing commands. On user manual, you can get all the commands. If we disable this telnet, 192.168.0.1, the same changes need to be applied. Changes are applied. Now if we read to 0.1, we're not able to connect actually. Connection failed because we disabled the let. If you enable it, save the configuration part, I can able to log in. It's asking a login. And see routing table. What must be configured on routers to reach users to internet? What routing must be configured? Default route. Default route is enabled. Agree?
Yes, global network ID.
Global network ID. So we are reaching internet. You can see firewall rules if we can configure. If you want to filter any websites, so you can filter. If you want to filter any MAC, you can through IP address you want to disable, you can write the IP address. No rules created for IP filter. You want to add, you can add the rule. So and so an IP user should not access network. Then you can write rule name. Rule name you can write and enter the source IP, destination IP. Like you can write some firewall rules here. Okay. So one by one, if you go through this, you can get to know what need to be configured, how to configure everything. Like this, we can configure Wi-Fi route. DNS. Let's see, any VLANs are configured now. VLAN list, yes. So my connection is a part of one VLAN actually. They're not mentioned untagged ports, untagged LAN, untagged NAT. See, NAT is enabled, and WAN port. We can understand one by one more option. It's clear? No more doubts. Local network you want to change, you can change local network. Want to set up this. No. Yes. The device will reboot, will disconnect the network. No, it is not recommended to do it. I'm trying to change settings for LAN, local network. I don't see that option sequence where it is options. So these all devices are getting automatic IP address. 192.168.143. This is my device. Right. Let us cross check if we enter host name. You can see desktop 07 HBSNV. Desktop 07 HBSNV 143. So in this table, we can get on which device which IP address is running there. This is DHCP enabled. This DHCP we can disable manually, can mean static IP address we can enable. We can ask to every user to assign so and so network IP address. Adoption also will be there. Clear? Right. So we should have shared only WebEx web links, right, for course presentation and manual. So use this link, first link. So here, all labs packet tracer files are pre-configured to all practicals. So we can refer these labs. Almost we have 60 plus labs are files are configured. So this is what first link contains. Second link, all PDF, all material actually. Some textbooks. Like yesterday, someone is shared Todd Lamley textbook. Good. So like the type of stuff we have here also, but not the latest. And sample resumes, profile formats. Some useful stuff we have here actually. So you can utilize it. The last one, CCNA, already have shared which a lab manual. Okay. 3 links I'm sharing on chart. Done. Any more doubts? So successfully we have done with our CCNA training program. Like I hope so you have learned at least 70 to 80% of the Cisco content. And when you are practicing or when you are studying your advanced level or your personal studies, if you have any doubt, you can just drop a message in group so we can respond it. Or personally can ping me. I'll try to give a reply.
Sir, can you send any sample resume for the applying jobs on
Have
CCN?
shared the link, right? 3 links. In second link, you'll get a lot of formats.
Okay, sir. Thank you.
Not only CCNA, even for this Microsoft system administrator,
Okay.
all formats are finished.
Okay, sir.
Any previous practice tests for certification that we can,
See,
that
they
should
are deviating, man. Like we have a dumps in the older dumps. Even the dumps also you can see in the second link. But
second link. Okay, okay,
yeah, that is only for your just your cross-checking purpose. It's not useful for the examination actually.
okay.
So exam purpose, when paid dumps, that will be helpful actually. Even the paid dumps also